What's wrong with the PDO? I am Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, October 20th.
Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, essential data for outdoor people, all the time, no hype.
If you enjoyed the video, give us a thumbs up. If you haven't subscribed, please subscribe. Click the Stormsurf icon down in the lower right-hand corner of the screen and ring the bell. You get automatic notifications when videos are posted, typically on Sunday evenings. If you have a question or comment, write it up down below. We'd be happy to respond. And if you'd like to make a small contribution to the cause, you may hit the super thanks button down below, the heart with the $sign in it. With that, I'd like to thank the folks that donated last week. Our regular cast of contributors, Tim Caston, Our Predicament, Evolution Moto, and then some fairly new contributors, Sully B. and Pierre Morton. Thank you all very much. With that, let's get to work. We'll start by looking at significant wave heights for the entire planet. Starting in the North Pacific, really not a whole lot going on. A little cutoff low, maybe north of Hawaii, but not doing anything. In the Southern Hemi, remnants of a gale that were somewhere down here in the South Central, Southeast Pacific, but again, nothing too impressive there. A reasonably strong area of seas pushing into Ireland in that area. Looks like these are the highest seas over the entire planet at 39 feet. And then over in the Indian Ocean, kind of a quiet pattern, 24-foot seas in a couple locations, and even less in the South Atlantic. So for right now, a kind of a calm pattern, a break in the action, if you will, for the entire planet. Let's start by looking at current conditions. We're going to start up north, Pacific Northwest, Grays Harbor off of Washington, buoy number 036. These, again, are current conditions. We're looking at all the energy that's hitting that buoy, all the way up from really high energy, 33.3 second period energy, which there is 0.0 feet of, all the way down to 5 second period wind swell. You sort of get the drill here. Peak energy in the 9-10 second period range. That would be just pure wind swell and really no other meaningful secondary swell. We can see it all pulled out right here. Primary swell, 5.3 feet at 9.9 seconds from 263 degrees. That would theoretically make surf at 5.2 feet, and it's that big or maybe even bigger from what I can tell up around that way. And then there's lesser period wind swell intermixed. Again, 5.8 feet at 6.6 seconds from the southwest. And that's just getting buried in everything else there. So pretty much a wind swell scenario for the Pacific Northwest. Then we move south into Northern California or North Central California. The Point Reyes buoy, 029. They're just north of the Golden Gate. Same sort of deal, same profile, no high interval energy hitting the buoy. It's all wind swell and even smaller. Yeah, a little bit of dribbles and stuff in the 13 second period range, but the peak energy, again, right around 9.9 seconds. Put it all together, primary swell 3.1 feet at 10 seconds from 300 degrees. That would make surf theoretically at 3.1 feet, and that's about what it is, about waist high, maybe some chest high peaks sort of thing, and then even lesser period wind swell buried under that. Then we head south to Southern California using the Point Loma South buoy off of San Diego there, buoy number 191. Even less of a pattern, though there is a third of a foot at 18 seconds theoretically hitting, and a whole bunch of just spread around, nothing even hitting 1 foot. That's not a good sign. Primary swell 1.4 feet at 8.6 seconds from 263 degrees. Now, the primary swell is selected by adding together the frequencies that when added together and computed to calculate maximum surf size, this is the frequency band that is theoretically computing maximum surf size. So that's not really good. Primary surf from primary swell 1.2 feet. So and looking at cams down south, yeah, it's pretty small, thigh high, maybe waist high, something like that. And secondary swell 0.9 feet at 12.1 seconds, and okay, a tenth of a foot smaller, 1.1 feet. But you get the general idea. Not a whole lot going on. So then we head over to the north shore of Oahu, Waimea Bay buoy number 106, north shore of Oahu. We do have a little bump of something here in the 9-11 second period range. Put that all together, 1.8 feet at 11.3 seconds from 330 degrees. That would make surf theoretically at 2.1 feet. It's actually bigger than that. I mean, there's for sure chest to maybe shoulder high sets at select spots on the biggest swell, you know, if you're there, you get it sort of thing, but at least it's reasonably rideable, and then wind swell in the mix there as well. All right, so let's go do a quick retrospective, looking at Hindcast. What have the wave models show have been going on for roughly the past week? In this case, for the North Pacific, we're going back to Friday, the 11th of October. Little gale developed here, falling out of the Bering Sea into the northwestern Gulf of Alaska with seas 28, 29 feet, then fading from there. Swell hit the coast of Northern California on Monday and made some decent rideable waves. You know, nothing huge, but overhead at select spots. That swell long gone. And since then, we're just looking for anything. We're here we are on Saturday, the 19th of October, nothing. And then we get into, to Sunday, and there you go. Just not a whole lot going on. So a relatively slack pattern of the North Pacific. Then we go down south, same sort of thing. We're starting on Monday, the 14th of October. Now, a gale did develop in the Southeast Pacific, producing, here we go, 33.9 foot seas. These are the highest seas over this entire domain for this one time period. We click the frame. Still 33.9 seconds and gives you the coordinates. So you can use this if you go dig around on the Stormsurf website to figure out, you know, what's going on depending on what ocean. Anyway, as we got into Tuesday, 15th of October, that swell started fading out. Swell energy from this is pushing or propagating north, expected to push into California starting the early part of this work week. Then looking out beyond, another gale developed right there on Friday, so just 2 days ago, with 31.3 foot seas to 31.7 foot seas into Friday afternoon. Lifting well to the northeast, fading from there. Swell from that is also radiating north. So two southern hemi swells en route to, well, this second one here, sideband energy into Hawaii, the first one and the second one, both into California. So at least some southern hemi swell is in the forecast. Let me go take a look at the North Atlantic. We're starting on Monday, the 14th of October. Not a whole lot going on right here for the moment. We're looking Europe. Swell pushed in on Wednesday, Thursday. Another gale developed off of Greenland with 30 foot seas. It said, we'll say 29 foot seas. That swell has already arrived in Ireland and United Kingdom as well. And then late on Saturday, another system building and just pushing into Ireland now with 39.9 foot seas. So a rather local and likely very windy and blown out set of seas for that area. For the South Atlantic, well, the winter time down this way is fading. Not a whole lot has been going on. We'll run through this. We're into Wednesday, Thursday, Friday, a little gale. Let's see, we got, what was that, 27 foot seas on Thursday night into Friday, propagating. You can see some swell pushing towards South Africa. But after that, a pretty quiet pattern indeed. And then finally, the Indian Ocean, 27 foot seas on Monday, the 14th of October, pushing through the South Indian Ocean and then fading. But you can see some swell generated pushing up towards Bali, Mentawai Islands, and into Western Australia. That was started hitting Western Australia on Friday, and you can see it just about poised on Sunday to start hitting Bali and the Mentawai Islands, but really not a whole lot behind that. So we'll do a deep dive now for the North Pacific, but of course, everywhere on the planet we're going to touch on a little bit, so no one will be left out. We're going to start by looking at Jetstream level winds. These winds up about 30,000 feet help support the formation of gales when those gales form. They help direct their track. We're looking for a trough, a push in the jet to the south, And we see that right here. That helps create a counterclockwise flow aloft and down at the ocean surface. That is the hallmark of low pressure. And of course, low pressure gets traction on the ocean surface, generates seas. Those seas start radiating away from the fetch area. The lesser period elements start fading out or decay, exposing the longer period swell energy. And of course, swell when hits your beach turns into surf. But it all starts with the trough in the upper atmosphere. So as of Sunday morning, there is a bit of a trough here in the, I'll call it the northern Gulf of Alaska, but also notice this big ridge here pushing up into the Bering Sea and even north of that, well up into the Arctic Circle, then falling south, creating a cutoff, almost a cutoff low or a pretty strong backdoor sort of trough thing over the date line. We'll see whether that produces anything, but you also see the next hints of a little trough developing here off of Oregon on Sunday. We'll put this into motion. The trough off of or over the date line gets completely cut off and it's just out, has no energy left. But you get this super pinched backdoor trough on Tuesday off the Pacific Northwest. It does the same sort of thing, basically cut off, but creates enough of a circulation that maybe something will happen down at the ocean surface on Wednesday, the 23rd of October. And then that one starts pushing into the coast. Another kind of these almost a backdoor trough starts developing in the northwestern Gulf of Alaska Thursday night, the 24th of October, and then starts getting fed by stronger winds, 150-knot winds, pushing through it, adding more energy, as so some sort of gale possible on Saturday in the northern Gulf of Alaska into Sunday. Oops. And we'll just go back here. And that's about it. But I kind of cheated and looked at some of the longer range models. And this general sort of pattern is forecast to continue for the northern Gulf. So let's go down to the surface. Surface level pressure, surface level winds. Let's see if what is forecast for the upper atmosphere manifests itself down at the surface. So here we are on Sunday. There is some sort of a little low pressure system. Hawaii's right there, California off here, Kuril Islands, Japan, the Aleutians up here, producing 30 to 35 knot west winds, all aimed off in this direction, nothing at Hawaii, so no hope there. That continues on Monday, pretty elongated fetch of 30 plus knot winds, but again, all aimed off Japan, but a good long ways away. Doubtful any swell result for that at all. Now we know there's this backdoor trough thing supposed to dig out off of California on Wednesday. Sure enough, 35 to 40 knot winds with 45 to almost 50 knot winds forecast. That's probably a bit overstated, but that could generate swell, and you get the sense some of the fetches aimed at Hawaii, some wrapping around the southern quadrant, aimed at California. This would be North California here, Central and Southern California here. Also notice some sort of a tropical system. I'll believe it when I see it. Just doesn't seem realistic. Another tropical system off of the Philippines here on Wednesday. Put this into motion. The low holds barely into Thursday morning. You notice, let's go back here. It actually jogged a little bit to, or is forecast to jog a little bit to the west Wednesday night into Thursday. That will push more swell to Hawaii and then makes a push towards California. Good for wind swell. Tropical system theoretically continuing, but then as we get later into Thursday, the next system develops in the Gulf, North Gulf of Alaska with 35 knot northwest winds circulating there till about Saturday, the 26th of October, and then fading. Notice the track on this tropical system pushing up to the northwest. Not sure. Maybe there will be some swell for Southern California. Hard to say. And we'll just roll this out. Notice low pressure trying to reorganize here off the Pacific Northwest on Monday, the 28th. Some other kind of a low on the date line, but nothing super organized because the jet stream in general is up here. The general track is across here, falling down here. All major storm activity has to be supported by the jet stream, and basically we're not seeing a whole lot. All right, so let's look at the effect of those winds on the ocean surface. Here we are Sunday, the 20th of October. Not a whole lot going on, just that little low pressure system here on the date line not doing anything, eventually producing maybe 18. Yeah, there we go. 20-foot seas on Monday, the 21st. But again, aimed far away at neither at Hawaii or the U.S. West Coast. So we'll see. Kind of continues even into Tuesday. It's Wednesday when theoretically something finally pops up on the charts. What is that? 20, 22, 25-foot seas, somewhat aimed at Hawaii, then starting to wrap around the southern quadrant of the gale, pushing towards the U.S. West Coast, tiny area of 20-foot seas there. And that is the end of that system. The next one behind it only producing, let's go back just a little bit. There we go. We had 22-foot seas aimed south at the U.S. West Coast, and that really not much of anything. Again, this tropical system looks impressive, and another one over in the far West Pacific. We'll believe it when we see it. It's almost Halloween. Yeah, it happens, but I'm not real confident in any of this. South Pacific, here's the fading remnants of our latest gale that has produced swell. It's just going to dissipate out. Looking out beyond, you see this little area here of 35. Oh no, it's probably about 36-foot seas, but it's almost falling southeast. Don't expect any swell really to radiate up into California. Another system theoretically pushing under New Zealand with 27-foot seas, but it quickly dissipates. On Thursday, the 24th of October, another system with 28-foot seas, but everything aimed southeast, not at our forecast area. Yes, there will be swell for Chile up into Peru from these systems, but up for our main forecast area, nothing until we get to Saturday night, the 26th of October. Little gale forecast right on the hairy edge of the California swell window, seas building to 36 feet. And this mainly in the Southern California swell window and mainly fetch aimed, we'll say, at Peru and Chile, but not very well up to the north. Maybe some sideband swell could result. Now, here you go. We're still 37-foot seas. California, Southern California is about 118 west, so right here, all this east of the Southern California swell window. This looks primarily like a South America, Central America, up into maybe Mexico, South mainland Mexico type of event, and then we're done there. Then we go to the North Atlantic. As we said earlier, big system impacting Ireland as we speak. What you don't see here, it doesn't show up very well in the wave models, but there's this persistent fetch of northeast wind that's been generating steady swell for almost a week now into most of the southeast coast, sideband energy up into Cape Hatteras, the whole way down into Florida. And we can kind of keep our eyes on that. That's supposed to continue. There's even rumors that it might redevelop, but now it's not showing it on the models so much. There you go. You still see this, what is that, maybe 9-foot seas. That's good for wind swell. It, select breaks. There we go. It starts redeveloping a new low pressure, theoretically forecast Wednesday night into Thursday. Still have activity in the far North Atlantic. And then the low off of the southeast coast lifts and is out of there. It wraps up pretty good off of Greenland, targeting Ireland again, UK, and maybe down, hard to say, into Portugal, somewhat sideband energy. And then that is the end of that. The South Atlantic, not expecting a whole lot going on. Yeah, 27, was that 27 or 26-foot seas, but all falling southeast. Probably not, just a little bit of our front here relative to South Africa. Another system tries to organize, but really doesn't do a whole lot. And given, there we go, there's another one, but look at it, falling southeast, and it's almost a week out. I'd say odds are low of it even forming. And then the Indian Ocean will just go right through this. We see limited bits of activity, but nothing sustained, nothing large. It is, the shoulder season for there, so it's pretty much take what you can get. We're all groveling together. Local wind forecast for California and Hawaii. Right now, you can see a 1040 millibar bulletproof high pressure system just choking off the main swell corridor in the northwestern Gulf of Alaska. A little bit of low pressure off the Pacific Northwest coast, but relative to your Central California, North California, Southern California, Hawaii out here. I mean, light winds for California, trades barely 15 knots for Hawaii. As we get into Monday, a little bit of a front tries to weasel its way south. Northwest winds 10 knots for California. Almost no trades for the Hawaiian Islands. Finally, you get a little bit of wind. Northwest winds, high pressure, tries to sort of nose into the California coast. 15-knot northwest winds. And trades very light for the Hawaiian Islands. Wednesday, here comes the low off the coast. High pressure, 1042 millibars, holding, choking the Gulf off again, but maybe some energy from this backdoor trough. Northwest winds, 20, 25 knots for most of North California on Wednesday night. Trades very light for the Hawaiian Islands. Thursday, light northwest wind pattern, really close to the coast, considerably weaker. Trades southeast at 5 knots for the Hawaiian Islands. Friday, look at this big broad area of low pressure generating swell, light wind regime for California. As we get into Saturday, it all lifts off to the north, light winds for California again, trades light for the Hawaiian Islands. And yes, I'm kind of ignoring this because I don't believe any of it's real. And for this, for our purposes, it doesn't really affect either California or Hawaii. And then you see another low trying to spin up in the Gulf on Sunday, the 27th of October. But with some sort of a cutoff low or something trying to go on here south of Hawaii, but a week out, I don't believe any of it. Rainfall forecast for California right here. We see the Whistler area in British Columbia getting all the activity. It's almost like there's some sort of a dividing line somewhere between Canada and Washington, holding all the systems off. Now a front you see is theoretically scheduled to push south this evening, making it to about Cape Mendocino Monday morning, getting some rain there, but making it no further south. We know we have another system developing off the coast. There it is. But California and the Pacific Northwest, high and dry until you get to Saturday, almost a week from now. Good dose of rain looking, again, all this range of mountains here, the coastal ranges of British Columbia on down into the Pacific Northwest, getting rain. It completely evaporates when it hits the California border. And we're into a week out now and no real change. That said, we're going to look out 10 days. This is the GFS model going out 10 days. We're looking at the snow forecast dashboard for Palisades, Tahoe, formerly Squaw Valley. And theoretically, the models are suggesting 2 feet of snow out on October 29th and 30th. I'll believe it when it happens. Let's go take a look at a couple other places. Kirkwood to get in on the action too, almost 2 feet of snow forecast there. And Mammoth with nearly 1.5 feet, and my guess is if the model went out a little further, you'd see the snow accumulation building there as well. And just for laughs, let's go north of the invisible border. We'll go up to Whistler and take a look, and you see a steady building snowpack with theoretically nearly, we'll say 34 inches of snow forecast over the coming 10 days. Looked at the cams up there recently. I mean, there is snow in the upper portion of the mountain there. It's not skiable snow, but there is this steady kind of base trying to get set up. The ground's trying to freeze. It's oscillating between rain and snow, but winter definitely looks to be trying to set up for the far Pacific Northwest or Canadian Maritimes, whatever you want to call it. And not that I think that anybody's still on the Pacific Crest Trail, but who knows, maybe they are. So we're looking at the temperature graph for the intersection of the Pacific Crest Trail and Tioga Pass Road in Yosemite National Park. The intersection there, that's about 8,700 feet. Freeze level now pretty consistently at about 12,500 feet. You see, and down at the hiking level, temperatures 45, 50 degrees, maybe warming up to 55 degrees briefly on Wednesday, the 23rd of October, but then hanging back down about the 45-degree range until you get into October 29th, and then temperatures just bottom out. At 8,700 feet, theoretically, temperatures down to 20 degrees and maybe even colder beyond that. So my guess is if you're on the trail, you've got about a week left or so before things start getting nasty. And certainly the further north you go, it's already getting nasty up there. So doing a quick look at surf spot forecast, just generalized Columbia River for the Pacific Northwest. Surf heights in the 6-foot range right now, holding into Monday morning, then pretty much trickling down to nothing until things start waking up in the northern Gulf later next weekend, and then surf heights up into the 7.5-foot range. Swell sizes, 6 to 7 feet at 10 seconds right now, fading down to just, 1 foot at 7 seconds or something, then building up to 6 feet at 13 seconds or something as we get into next Sunday. So maybe an opportunity there. Down in Northern California, well, small southern hemi background swell, supposedly showing up surf heights in the, it's hard to say here, we'll have to go look at the swell thing, but in the 3-foot range, basically, 2.5 to 3 feet. Trickling down from there, then the swell from the gale forecast off the coast arrives on Friday or Saturday of this coming week. Surf heights maybe to 7 feet, and then quickly fading down from there. Here we go. Here's that 1 foot at 16 seconds on Monday, building a little bit more, 1.4 feet at 17 seconds, 1.6 feet at 18 seconds with this background noise of 4 feet at 8 seconds, all mixed together, and then eventually some semi-real surf in the 6 feet at 11-second period range for next weekend. So for the most part, an all clear if you're working. You're not going to miss a whole lot. Going to Southern California, Dana Point, southern hemi swell, much more pronounced there, much less wind swell to interfere with it. The graph depicts this pretty clearly. Surf heights building into 3.5-foot range, and that's just at any old beach at some spot that has good bathymetric enhancement. You'll get surf heights maybe even double, well, not double that, but maybe 1.5 times that. So that'd be on Wednesday, 3.5-foot surf. Then some sort of background energy holding the whole way through the rest of the week. Swell heights, 2.2 feet at 16 seconds at its peak, but energy arriving as early as Monday, building through there, and just slowly holding on 1.5 feet at 12.5 seconds, even in next Saturday and Sunday. So surf for Southern California, at least rideable and better than what it is now. North shore of Oahu, pretty slack sort of surf pattern, 2.5-foot surf, maybe starting to build as we get into Thursday, 4.5 foot, maybe up to 6 feet as we get later in the work week. Swell heights, 4.8 feet at 10 seconds. This is that sort of background swell until you get into swell from the Gulf of Alaska, I should say, and then another pulse 5 feet at 12 to 13 seconds on Saturday. Going over to the U.S. East Coast, we'll try Florida, Cocoa Beach, right in the middle of the East Coast there. Surf heights in the 4-foot range, slowly fading to 3 feet, pretty much the whole way through the work week. All out of the northeast, steady onshore flow for the most part, creating some swell. Swell heights in the 5-foot range at 8.5 seconds, slowly fading down, all of it in the 8.5-second period range, even the whole way through. So surf pretty much for the entire week. That is a good deal for the Florida East Coast. And then finally up to Cape Hatteras, the lighthouse there, North Carolina. Now they're getting more sideband energy, less direct swell, but surf heights 4 feet fading into the 3-foot range, maybe a little pulse up again on Friday early and then fading some from there. Swell heights 4.5 feet at 9 seconds, 4 feet at 7 seconds, 4 feet at 8 seconds, then back to 4 feet at 7.5 seconds. So rideable surf for sure. All right, let's go take a look long term. We're going to look at the two major weather oscillations that affect the potential for swell generation. They are the MJO, the Madden-Julian Oscillation, and the El Nino Southern Oscillation. And just as a reminder, we will be talking about the PDO a little bit later in the conversation here. This is all the fundamentals and the build-up for that part of the discussion. we're going to start talking about the MJO, the Madden-Julian Oscillation. There are two phases to it, the active phase and the inactive phase. The active phase and the inactive phase rotate around the planet from west to east on the equator. The active phase is our friend. It's a low pressure system. When it's over the Pacific, it takes warm, moist air from down at the ocean's surface, lifts it up into the atmosphere. That in turn gets caught up in the jet stream, feeds energy to the jet stream, making the jet stream stronger. It digs out troughs. It doesn't split. It consolidates. And that's good for storm production over the Pacific. Inactive phase is effectively a high pressure system. It cuts off the flow of moisture up into the atmosphere, steals energy from the jet stream. The jet stream splits, and then you don't get any favorable conditions, or not nearly as likely to have favorable conditions for storm development. So we're going to start looking for signs of the active phase of the MJO. Because the active phase of the MJO is a low pressure system, it reduces trade winds. Trade winds are generated by high pressure in the Pacific. The inactive phase of the MJO feeds high pressure and increases trades. So we're looking at data from the TAO buoy. You see of buoys strung across the equator. This is the West Pacific here, East Pacific here, the equator there, the date line right there. These are 5-day average winds. We're just looking at the arrows. The other part of this is water temperatures. You can see giant sections of this whole array are down. They're doing maintenance on it. I think it's like a year-long project, but we still have at least some hints of what's going on in these areas. We see the longer the arrow, the stronger the wind. So strong trades out of the east in the East Pacific, strong trades over the Central Pacific, pretty strong trades over the West Pacific. This does not look like at all like the active phase of the MJO. It looks like the inactive phase. We can confirm that by looking at anomalies. This is the difference in average wind speed for each little location on this chart over a 30-year period. So you can say, are the winds stronger than normal or weaker than normal? And that's how you can kind of tease out whether the MJO is active or inactive. And limited to the West Pacific, that's really where we're most interested. In the East Pacific, winds, you look at the arrows, little arrows out of the east, trades a little bit stronger than normal there. In the Central Pacific, a little bit stronger still. In the West Pacific, a little bit stronger still. All this smells of the inactive phase of the MJO. And again, looking at the models and sort of this sort of lackluster swell pattern, all seems to suggest inactive phase of the MJO for the moment. Let's dig deeper. Next up, 850 millibar zonal wind anomalies. Basically the same thing we were looking at. Are the trades stronger than normal? That's the blues. Or weaker than normal, or if anything, turning westerly, that would be the reds. Okay, now this is the whole planet on one chart. The date line, you can't see it. There you go, 180. The date line runs right up the middle of the chart. The far West Pacific starts here at about 125 east. Okay, and it's important, the active phase of the MJO does its best magic to feed the jet stream upstream of the jet stream. So when over the West Pacific, then that in turn feeds energy to the jet stream. So when it moves over the date line and into the Gulf of Alaska, it's powerful, troughs are digging out, and it's doing its magic. All right, so we can, and the main area, so 125 east, that's the far West Pacific, to about 170 west right here. So this is past performance here. Blues, easterly anomalies, inactive phase of the MJO. So you see, just starting about October 15th, it looked like westerly anomalies just starting to nudge into the far, we'll do this here, into the far West Pacific, 125 west, but strong easterly anomalies in control, forecast into almost Halloween, and then what I'm guessing is the inactive phase and easterly anomalies start collapsing, and westerly anomalies start building, almost filling the Kelvin wave generation area, the West Pacific, into the end of the model run, November 4th. Yesterday's model and the day before that looked a bit stronger, but the model varies from day to day. Either way, looks like finally this inactive phase that has been in place the entire month of October is finally going to fade out. And typically, this is pretty normal. It takes about 4 to 5 weeks for one phase of the MJO to traverse the Pacific. So if this started September 25th and it's going to wrap up on October 30th, that's about 5 weeks, something like that. So not unusual. After that, active phase and our friend opens up the window. So as we get into November, maybe better opportunities for storm and surf production. So with the active phase of the MJO taking warm, moist air and lifting it aloft, when that warm, moist air hits the upper atmosphere, it's much colder up there, it condenses and creates clouds. And it would create more clouds than is normal for this time of the year in wherever the active phase is. You can see that here on outgoing long wave radiation forecasts. The blues are skies that are cloudier than normal. The red or the yellows drier than normal. So this would be like the inactive phase here. This would be the active phase. So theoretically, according to this is a statistic model, the CA model, there it is. Active phase already starting to build in the West Pacific, forecast holding 5 days from now, continuing 10 days from now, fading some 2 weeks from now. So that looks like an improving pattern. The dynamic model, the GEFS model, basically painting the exact same picture. We see there's the last frame. Statistic model a little bit stronger, but in either case, it looks like a favorable pattern is coming. We are finally reaching the end of what has been a fairly strong and robust inactive phase of the MJO. Here are the phase diagrams for those two models, statistic model here, dynamic model here. How do you read this? Well, the MJ moves from west to east, from the Indian Ocean over the maritime continent, that'd be like Bali, to the West Pacific, to the East Pacific, under the United States, across the Atlantic, over Africa, back to the Indian Ocean. The heavy dot is where the active phase is, and the further the dot is away from the circle, the stronger it is. So a modest active phase in the East Maritime continent, forecast moving into the West Pacific. 1, 2, 3 different flavors of the model. 2 of them suggest, well, it crashing into the circle, so that means very weak. The other one suggests the active phase building to modest, almost moderate strength about 10 days from now, and then collapsing. The dynamic model, the GEFS model, painting the same picture, but with the active phase racing east a little bit more in 2 weeks from now, out of even the East Pacific, over the Atlantic somewhere, still at moderate strength. The upper level model, much like the outgoing long wave radiation models, suggests areas favorable for precipitation or moisture at the jet stream level in the atmosphere. This runs about a week to maybe even almost 2 weeks ahead of what goes on down at the ocean surface. Let's look at our chart. That is South America, Central America there, New Guinea there, the equator there. Date line running right down the middle. Each panel is 5 days long. There are 8 different panels, so this goes out 40 days. You see the active phase of the MJO forecast traversing the Pacific through about November 4th, but really, remember, that's ahead about a week and a half, so till about mid-November. Then here comes the strong inactive phase as we get later into November, pretty much locking things down till you get to about Thanksgiving, and then the next active phase forecast moving into the far West Pacific. And then the CFS model. This is 850 millibar winds again, so the blues are easterly anomalies, and this has the MJO, the solid black contour. So the solid black active phase of the MJO with the reds, that's westerly anomalies. Here's your inactive phase with blues. Now this was back in July and August, so you can see active, inactive, active, inactive. Here's today, well, it's actually yesterday's model. So this suggests the inactive phase in control for about another week over the date line, while the active phase starts building in the far West Pacific, even starting 2 days from now, making its way. This run of the model actually looks better, showing westerly anomalies just about making it the whole way across the Pacific through the latter part of October into mid-November. And then after that, dotted contour, inactive phase, strong easterly anomalies taking over. This site was down for a couple of weeks. That was, and I'll show you the site right here. Carl Schreck produces this model. This data center was out of North Carolina, was taken out. It wasn't taken out, but power was shut down by Hurricane Helene up in that area. Also, a lot of the NOAA data, it was housed out of that data center as well. It's now all back online. The altimetry data that we display on Stormsurf, it's coming out of that data center too. And those of you that follow altimetry know that, you know, it was not updating for a couple of weeks. Well, it's updating and everything appears to be normal now. Thank goodness. And then finally, the CFS model going out 3 months. Past performance down here, the forecast up here. This is 850 millibar zonal wind anomalies. Again, the blues, easterly anomalies in active phase. The yellows, westerly anomalies, the active phase. Date line runs right up the middle here. Far West Pacific starts at 125 east, so right here. So the area we're interested in is really right along in here. You can see strong easterly anomalies forecast for the next week over the dateline region in active phase, while the active phase starts building in the west, tries to make progress, but kind of falls apart as we get into the early part of November with just sort of this mixture of east and west anomalies. And then theoretically, as you get later into November, it looks like another active phase and westerly anomalies taking over. Let's overlay the MJO. So here you go, inactive phase, the dotted contour, traversing the Pacific into about the next week. After that, active phase makes its trek across the Pacific. Now, it doesn't show the westerly anomalies quite as strong or as robust as that previous model we saw. Then inactive phase, weak easterly anomalies as we get into mid to late November. But then once you hit Thanksgiving, active phase theoretically coming, westerly anomalies taking over. So at one point, this model was showing somewhere around early November, westerly anomalies filling the Pacific and La Nina just basically all but gone. Now, not so much. Let's overlay the low pass filter. This clarifies the situation a little bit. No solid contour, low pressure, the low pressure bias, the El Nino signal, the El Nino low pressure over the Indian Ocean. Classic La Nina kind of setup, but not strong. With high pressure, tried to set up over the dateline, but failed in early August, and is only expected to come back as we get to maybe about 5 days from now. One contour, not particularly strong, not looking impressive at all. This La Nina, whatever it is that's trying to get organized, at least per the models, does not look impressive at all. And when you get down to the surface and start looking at stuff, it's maybe even a bit weaker than that. All right, so if La Nina were developing, it should rearrange the water in the Pacific Ocean on the equator, the temperatures of the water and where the warm water and the cold water is. So I look at data from the TAO buoy array. Again, that series of buoys strung across the equator. They have wind sensors, but also notice these are the anchor lines. There are X's on those anchor lines. Oh, and if you notice, look at this. There was a big old gap here for months. It's now filled in. So they have been doing maintenance on the buoys, and more sensors are online. We have a better, theoretically, picture of what is going on subsurface water temperature-wise. This is great news. All right, so we start by looking at the 29-degree isotherm, actually the 30-degree isotherm, which was here. It's gone, suggesting trades blowing maybe a bit stronger out of the east, or at least more consistently. The 29-degree centigrade isotherm, about where it was last week at 180 west. The 28-degree isotherm, about where it was last week. I think it was 168. It's maybe slipped by two degrees. That's, what, 120 miles? That's not much of a slip for looking at the scope of the Pacific. The 24-degree isotherm, a little bit shallower right here, but still pretty much going the whole way across the Pacific. So no clear signs of like major cooling going on. And here we go, anomalies looking subsurface. Now that we have data online here, because I think this one and this one were both, these two sets of buoys were both out. They're both online now. We see 2 degree below normal anomalies. We see 1 degree above anomalies here in the west and maybe some more in the east. And we do see a path here now, at least according to this, for cool water typically it migrates down like this, not up from down here. So I'm not sure that there really is a path for more cold water to develop pushing east. We'll need more data on that. So with that, let's go look here at the next chart. Same kind of chart. It just it uses satellite data in addition to the buoy data to get a sense of what's going on. And the satellite data is not temperature data, it's the height of the ocean. We'll get into that in a minute. Anyway, warmer than normal temperatures here now over a broader area, filling the whole way to 160 west, and then cool anomalies limited to 160, pretty much from there over the eastern half of the Pacific at, let's see, 1, 2, 3, 4, 1, 2, 3, 4. Now this says 4 to almost 5 degrees below normal. That's pretty cold. The previous model, well, we'll just go up here and look, doesn't show any of that. So a little bit of a disparity between the two models as to the exact amount of cold water in the pipeline heading our way and how much of it will eventually reach erupt up to the ocean surface over time. So here's the satellite data used to build that chart. This is, I think it's the Jason satellites and probably some others. They map the height of the sphere of the ocean. Is it higher than lower? Take out the wind waves, take out the tides, take out actual swell, and is the sphere of the ocean higher or lower than normal? And we're talking centimeters. We're talking like, this much difference sort of thing. Why does that matter? Cold water at depth contracts. When it contracts, the water above it will sink to fill in the void. You'll get negative anomalies on the surface, just like what we see here. Warm water at depth expands, displaces the water above it upward. You get positive anomalies like here. So this is the equator, this is the date line. Chile, Peru, the Galapagos, Central America, Hawaii here, New Guinea here. Colder than, well, one can infer, I'll say negative anomalies, minus 10 centimeter anomalies right here, in between about 120 west to 140 west. So not that deep. You'd really want to see minus 15 or even minus 20 if you were in some major La Nina. Fortunately, we're not seeing that. That's good. This is pretty modest in all. And you see warm anomalies over here in the West Pacific. All this suggests trades are blowing, scooping out cold water, pushing it this way to the west. All warm water building up in the far West Pacific. We're in recharge mode from last year's El Nino. And you can see that pretty well here. Upper ocean heat anomalies. This is over the past year. West Pacific here, East Pacific here. Last year in November, December, our El Nino taking warm water, pushing it from the West Pacific to the East Pacific. The warm water pool in the West Pacific got tapped out, cold anomalies upwelled, and then we started a cold water Kelvin wave cycle. One here in January, another one in March, another one in April, May, another one in July, August, the latest one in September. Thought we were done. It's trying to build back a little bit, but I'm not seeing anything that suggests yet another major cold water Kelvin wave pushing across the Pacific. I don't know. We'll see. Let's dig a little deeper. Sea surface temperature anomalies, all right? Deviation from normal. South America, Central America, Australia, New Guinea, equator right there, date line right there. The blues, colder than normal waters. So we see this pattern of if the trades are blowing stronger out of the east on the equator, you get upwelling. And if you have a bunch of cold water down deep in the ocean driven by those easterly anomalies, then you get cold water upwelling to the surface. And that's what we have here. This is probably close to the most pronounced the cold water signal has been so far in anywhere in this La Nina cycle to date. So definitely clearly suggesting some sort of La Nina trend underway. In fact, the trend for the past 7 days, well, there's some warmer water developing off of Ecuador, but here are pockets of cold water out around 120. I mean, this is almost like a Madoki La Nina sort of thing. It's not developing right up there along South America, which is exactly what you'd want to see. In fact, we can go back up here. You can see there's generalized cool water. Remember, this is the trend here. This is the actual deviation from normal. Most of the cooling is out in the central Pacific. Now, why does that matter? Well, where the cold water is, if you have colder than normal water, that does not support evaporation. If you don't have good evaporation, then you don't get clouds building on top of it. You get high pressure building on top of it. And right here in the middle of the Pacific, we have cold water. Likely that would be feeding high pressure up here in the Gulf of Alaska and also south of it in the central South Pacific. And that is clearly a La Nina signal. But if the cold water was more here, that would have more of an impact, I think, into interior the United States. And typically, the more eastward displaced a La Nina or El Nino is, the stronger it is. This hints of a very weak La Nina, just given the positioning of the cold water. The sea surface temperature trend in the area right there along the Galapagos and Ecuador, it's called the Nino 1.2 region. Current temperatures, 968 thousandths of a degree below normal. That's almost 1 degree. So cold, but not freezing cold. Let's go look at the official El Nino monitoring region, the Nino 3.4 region. This is the area from south of California on the equator, just 5 degrees north and south of the equator, from a point south of California out to about the dateline. Current temperatures, 1.05 degrees. So these two charts are both saying about 1 degree below normal temperatures. This is not the official record, though. And also with that North Carolina data center coming online, finally we have our weekly sea surface temperature anomalies. This is the official record back up and running. This is Nino 1, Nino 1, Nino 2, Nino 3, Nino 3.4, Nino 4. This is the one that matters right here. You can go back in time to June. You see temperatures were hovering right around zero. They've been just barely dipping into the negative territory. It is only on October 9th, so the last reading, half a degree below normal. That is the official record. It is still bad. It's like 11 days old, though. We'll have an update on Monday. We'll see where we're at. But the trend generally is negative, but it sure isn't moving much. I mean, zero is zero. It's neutral, neither El Nino nor La Nina. And we're still at 0.5. That's the beginning. In fact, I'll show you here. The official record was at October 9th. Put the value at half a degree right there. Okay, from 0 to plus half a degree to minus half a degree is considered completely neutral. Neither El Nino nor La Nina. When you're half a degree to 1 degree below normal, that's considered weak La Nina. And remember, it's not just one reading. It has to stay that way for like 5 consecutive months. So we're just now, according to the official record, just putting our toe into the La Nina territory. And here it is almost Halloween. And typically La Nina peaks out somewhere between Thanksgiving and the first 2 weeks of December. And if we're only 5 weeks away from that, I mean, we're not in a very bad situation at all. In fact, this is looking pretty good for a La Nina. So what does the atmosphere think is going on? Okay, if you're in El Nino, you have warmer than normal water temperatures over the eastern Pacific. That supports evaporation, that supports cloudiness, that suggests lower pressure in the East Pacific, and pressure, therefore, in the Pacific would be lower than normal. This is the and during La Nina, the exact opposite happens. You have colder than normal water, just like what we saw. You get high pressure developing on top of that. And so they've built an index. The difference in pressure between Darwin, Australia, and Tahiti in the Pacific, Darwin roughly over the Indian Ocean. When pressure is lower over Tahiti, the index goes negative. Well, today's value is plus 11.41, suggesting higher pressure over Tahiti relative to Darwin. But you kind of go back and look here, well, wait, it was minus 11 just 5 days ago. You can look back and it's been generally more positive than negative, but not strongly so. So you do a 30-day average here, and the value today plus 1.33, that's basically neutral. If you're in a decent La Nina, you want to be at least at plus 7 or plus 10 or something like that. Let's go back and look over the past month. Well, yeah, we were higher a month ago. It went slightly negative. Now we're slightly positive, but clearly still in the neutral territory. So let's go look out 90 days. The average 1.96. Again, pretty much neutral looking back. Yeah, we were not a whole lot different. Again, in fact, let's look at this on a graph. That illustrates it even better. Here we go. So if you're up in the blue, this is La Nina. You're down in the red, this is El Nino. That was our, back here in 2022, this was the end of our big La Nina, our 3-year La Nina. Then we fell into El Nino in 2023, but pretty weak El Nino. You can see just barely in the El Nino category. And then since about January, we've been hovering in neutral. If I were to draw a trend line through this, you could see, yeah, it's maybe trending upward, but still clearly right smack in the middle of dead neutral. Neither El Nino or La Nina indicated per the Southern Oscillation Index, which is a pretty good indicator of what's going on in the Pacific Basin. So what is the forecast for sea surface temperatures in the Nino 3.4 region? We have the model from the CFS version 2 model. Again, I don't think this model is even believable because they just updated temperatures, and in October they showed it at 0.85. This was mid-October. We just saw back looking, we looked at the actual values. It was 0.5 as well. So, I'm sorry. 0.5, not 0.85, okay? But the model had previously showed temperatures should be down at like minus 0.85 in October, and then the actuals hit it, and then it all corrected, and now you see it still dropping hard off a cliff almost down to 1 degree as we get into November and December. I don't think we're going that low. The good news is the consensus forecast is going to update tomorrow, Monday or Tuesday. So we'll catch that in the next video. But it is all the other models have been consistently suggesting something in the maybe 0.6 or 0.7 degrees below normal. And again, minimum La Nina starts at 0.5, and you're not even into medium La Nina to -1. So weak La Nina looks to be the forecast. So that brings us to one last area of discussion. The PDO, the Pacific Decadal Oscillation. And let's go look here. The actual definition of it from NOAA's website, which again is finally back up online. It was down because all this data is housed out of that same North Carolina data center. In parallel with the ENSO phenomenon, the extreme phases, of the PDO have been classified as being either warm or cool as defined by ocean temperature anomalies in the Northeast and tropical Pacific Ocean. When sea surface temperatures are anomalously cool in the interior North Pacific and warm along the Pacific coast, and when sea level pressures are below average over the North Pacific, the PDO has a positive value. When the climate anomaly patterns are reversed with warm sea surface temperature anomalies in the interior and cool sea surface temperature anomalies along the North American coast, or above average sea level pressure over the North Pacific, the PDO has a negative value. And this is key here. Above average sea level pressures over the North Pacific. That is the core of where all our winter storms come from, right? If pressure is higher, well, storms and surf is made from low pressure systems. Those low pressure systems, if they're in an unfavorable environment of average higher than normal pressures, will have less chance of being strong, getting traction on the ocean surface, generating surf. Okay, and we talked about this some, I think it was last week or the week before, and I did a sort of a quick rough chart and found that in average, it seemed like sea level pressures have been rising steadily in the North Pacific over the past 30 years. All right, so here is the Pacific Decadal Oscillation. We've been through this before. It goes back to 1854, but that's reconstructed data from like tree rings and things like that. I don't know how accurate it really is. Let's say from about the 1950s forward, that's probably a better version. I mean, sea surface temperature anomalies without satellites and without measuring all that stuff. How do you know what the pressure is in the middle of the North Pacific if you don't have a satellite and you don't have good modeling and all that kind of stuff? All right, so the point being here, I'm going to do a little thing right here. Let's see if this works. Today's value. September, that's the latest one. I've been waiting for this because the data center was down, minus 3.54. And you can see we've been just in this long run of negative anomalies consistent with the a cold PDO. You can see it right here. And we've basically been in this pattern since, again, 1998, okay? Big El Nino in 97. We've been in the cool phase of the PDO ever since. So we're looking at, what, 25 years roughly? Now that value minus, I got it right here, minus 3.54. Here's the 3 line. When was the last time we had readings that were way down that low? Well, we see we had some others right in here, but then you're back into 1954. In fact, the actual value, 1950, right here. There we go. And here we are, July 1950, minus 3.65. So that beats our current one. And the only other one colder or more negative was, look at this, April 1859, minus 3.65. So as of last month, right there, and then the other cold one here, and the other cold one here, we are in one of the 3 coldest, or in this way, I should say, the most negative phase of the PDO, which in turn infers the highest pressure in the North Pacific, only one of 3 out of the past, I don't know, almost 200 years. Now, again, I don't believe any of this data back here, but it suggests that the PDO is cold, it's dug in, higher than normal pressure over the Pacific. You wonder why, gosh, why isn't the surf as good as it used to be 10 or 15 years ago? Well, that's why. We have higher pressure. And if it's higher pressure in the North Pacific, it's also higher pressure in the South Pacific. The entire Pacific basin is not biased towards El Nino or low pressure. It's in a sort of a long-running La Nina pattern. Again, we've talked about this. We've been waiting for this pattern to break. I tried to do some just rough analysis and say, well, okay, if you're in the coldest part of La Nina, does that mean, or the cold phase of the PDO, if you're in the coldest part of it, is the end near? Well, I couldn't tell that by looking. There is no clear obvious association with that. So we are where we are. So where are we? Well, let's zoom back to current time. Here we are in this year. We're in a La Nina, a very weak La Nina pattern. Surf-wise, a little bit of a gale forecast for the North Pacific. Southern Hemi still chugging on almost in Halloween. Yes, not unprecedented. It happens often, but it almost seems like the Southern Hemi is more active than the Northern Hemi. The Northern Hemi will come online. I've been looking at the models. Some of them go out 2 weeks. Totally unbelievable nonsense, but they suggest a building pattern as we get deeper in. Again, I think the seasons are just heavily displaced by 6 weeks, maybe 8 weeks, maybe even more than that. Or maybe winters are just getting shorter, but I don't want to go down that rabbit hole. Either way, for right now, yeah, there is going to be some surf, but nothing big, nothing solid, but it's trying. And you can see the Northwest Pacific snow pattern suggesting little bit at a time, fall is trying to edge its way down the coast. We'll just see how soon it makes it. But the sense is we're in for some sort of a La Nina winter. Maybe it will appear stronger in terms of surf or lack of surf as compared to what the actual hard data suggests. But I think this PDO reading and the pervasiveness of constant negative PDO numbers suggest a high pressure pattern is pretty well entrenched over the Pacific, and it isn't going to be dislodged overnight anytime soon. So the pattern is, or the forecast is, or your strategy should be, if there's waves, you better get them, make the most of it. Don't wait for a better day ahead, because who knows when it might come again. All right, so that's our forecast for this week. If you enjoyed it, give us a thumbs up. If you haven't subscribed, hit the Stormsurf icon down in the lower right-hand corner of the screen. Questions or comments, write them up down below. And if you'd like to make a small contribution to the cause, you may. Hit the super thanks button down below, the heart with the $sign in it. And with that, we are done for this week. We will do it again next week, same time, same channel. Thanks so much for watching.